Hey everybody, I just wanted to go over a few things with you on your study guide and the answer key for the review worksheet. For the study guide, make sure that you are taking full advantage of the opportunity to write out formulas and even have examples. Notice the study guide, if you print it out, has two sides, front and back. So you can either print it out and use both sides, or you can write it out on notebook paper, but two sides only. So if you print it out and it's 2 pages, do not write on the back of both of those pages. Just having everything as quick reference for you will help you be super successful on the test. So writing the formula for slope of a line, what is slope-intercept form, what is general form, and how can you find slope? So these are all things where you can explain what to do and then have examples over here on the right. What's point slope form? What do you know about parallel versus perpendicular lines? So just all things from our topic or chapter 2A notes. What are the steps for writing real life application problems? What is the definition for a function? Can domains repeat in a function? What is function notation and how do you find specific function values? And then we had those 4 kind of key breakdown rules to help determine domain. Make sure to look not only at the video lesson for that, but the Google Meet notes that we did as well. Now I don't know where the rest of that page is. Hang on. Oh, gotta go to the second page. Okay. So remember on something like question 11 where it says, how do you find values of x for which f of x equals 0? So remember here to set the equation equal to 0 and solve for x. Set equation equal to 0 and solve for x. Don't plug in 0 for x. That's a totally different kind of output value. So make sure to have an example for that if you want as reference. How can you determine the domain and range on a graph? How do you read the graph? So here's domain, range, finding zeros. How does vertical line test help you determine whether or not a function or a graph is a function? And then the last couple of questions we had to review our notes, taking a look at determining increasing, decreasing, and constant functions. How do you read the graph? That's simply from left to right. Determining is the graph increasing, decreasing, or going straight across at that time. So again, you guys, this was due on Friday, and I believe I have about a 50% turn-in rate on that. This needs to be submitted by the end of the school day on Monday in order to use it on the test on Tuesday. Please take some time to fill this out, whether you print it or write it on notebook paper, and submit it for credit. And now here are the answers for the review worksheet. Making sure that you always have work shown for credit, otherwise it doesn't really do you a whole lot of good to prep you for your test. So make sure you're showing work when work is needed. For number 1, the slope is 3/2 and the y-intercept is 0, -6. 1B, you wouldn't need work for this one if you recognize the slope would also be 3/2, but now the y-intercept is just 0, 1. Question 2, asking to write an equation that goes through 2 points. Just remember, identify them as x1, y1, x2, y2. Find the slope and then plug it into point slope form. Simplify, and that should be your answer. Question 3, kind of along that same line, write an equation that's parallel and perpendicular to the given line, and then passing through the point -3, 1. This is going to be your x1 and y1. Find the slope here first, and then determine what makes them parallel, what makes them perpendicular, and write your equation accordingly. We had a couple of application problems, Carl's Cat Toy Company, and then the sequoia trees, so taking a look at both of those. Writing an equation of a line that represents the value of the company from 2012 to 2015, and then using your equation in A to predict the value in the year 2020. So when you write these ordered pairs, remember one of the big things we talked about is that time is going to be your input, and then whatever you're comparing is your output. So we're comparing the value of the company in millions of dollars, and in 2015, it increased quite a bit, which is great for that company. And then from here, you really don't even need the word problem anymore. Just identify your 2 variables, that's a y. Plug it into that point slope form, and that will give you the model. And then in the year 2020, you literally just plug in 2020 for x, and that will give you the value. Same kind of idea on problem 5. In 1965, The sequoia tree had a diameter of approximately 137 inches, and in 2005, the diameter increased by 4 inches to about 141. So again, here you'd have 1965, that's the year. What are we comparing? Diameter. And then in the year 2005, there's a change in that diameter. And there's your x1, y1, x2, y2. Find the slope, plug it into point slope form. That gives you the model as the diameter as a function of time. And then use your equation to predict the sequoia tree in 2050. Plug that in for x, and that should be the approximate diameter for trees based on that linear model. Number 7, just give you a function determining each of the following. The number that's in the parenthesis, that's what x should equal. So you just plug it in here and simplify, and you should get 21. F of 0, same idea. F of 3, same idea. When you plug in n plus 2, there's quite a bit of work on that one to get to this end result. So make sure that your work matches. If not, please let me know, and I would be happy to walk through it with you. On the back of the worksheet, we're looking at domain. We had 9 different domain options. There's a lot going on here. Be specific with the variable in your answer. Make sure it matches with the variable in the equation for the inputs. Sometimes it's all real numbers or your all real numbers symbol. I just didn't have that symbol on my computer to write that out. You don't have to have both. You can either write all real numbers or that symbol. Either one is fine. But then recognizing how some of them have restrictions or specific rules based on either a content question, if it's a rational function, if it's an even root, if it's an odd root. Linear, quadratic would make that a polynomial function. Well, this one's all real numbers too. So make sure to look through those, have work shown when needed to support them to get full credit. Question 9, notice the answers here are different. It says find the zeros and then find f of 0. 2 different answers here. To find the 0, set it equal to 0 and solve. If you're evaluating f of 0 here, you plug in x equals 0, and that would be what helps give you those 2 different answers for each of those problems. Question 10 is interpreting a graph, finding the domain and the range, evaluating for specific numbers for x. Remember, for those, you just go to what x equals on the graph. So if I count over to 1, 2, 3, my output is down here. So I go over 3, the graph is down at -2, and that's the answer. That's how you evaluate a specific input and output value. The zeros of the graph are where it actually crosses the x-axis. That's a 0 of the function. So notice it crosses the x-axis at +2 and +4. Those are the zeros of the function. Does it pass the vertical line test? Sure, just show some vertical lines through there. And it only intersects at most 1 time on the graph. That means this graph represents a function. So the domain goes left to right. Notice on that left-hand side, I guess I should have started with that. That left-hand side has an arrow, so it's going towards -infinity, this direction. On the right, it stops right there, so it ends at +6. Range bottom to top. For this answer, notice the lowest point on the graph is when y equals -2, but this arrow in the direction of going up goes towards +infinity, and infinities always have parentheses, but numbers where it equals have brackets. So watch the notation on that when you write that out. Let's see. Oh, and I didn't make this red. Oh, bummer. Okay. Sorry about that. Let's fix that. So these answers should be in red like the rest of them. There's no reason why they're not. So sorry about that. It's decreasing from -infinity to -2 on the x-axis because you're going from left to right. And it also decreases from +1 to +3. So both of those would match kind of here and here on the function. Then it goes constant. So you can write these in any order. That's not a big deal. It's constant right in the middle here from -2 to +1. The only time the graph increases is from 3 to 6. So from when x equals 3 to where the graph stops, that's when it's increasing. So as long as you can identify those values, you should be in good shape there. Okay, last but not least, we have our piecewise function. So this is where you have to look at, whoa, where's that red coming from? Sorry, pressed the wrong button on the left-hand side. Here we go. So when you look at a piecewise function, you're really focusing, everyone, on what values for x make sense for the first row, second row, and now we have a third row option. So taking a look here, is your x value less than 1? If it is, you plug it in the first row. If it's between 1 and 3, it means it could equal 1 but be less than 3, it plugs into the middle row. Or if it's greater than 4, you plug it into the bottom row. So you're really just trying to figure out, well, where's the most appropriate place to substitute x? Our first one was -2. Notice -2 is less than 1, so we plug it in here. -2 plus 1, and that's how I got -1. Plugging in 1, plugging in 3, plugging in 5, and you would get the appropriate outputs accordingly. Notice for a C, f of 3, it says not possible. So if we look at why can we not plug that one in, let's take a look at our values where x is valid. So for less than 1, 3 isn't less than 1, so that isn't true. Between 1 and 3, but notice it can't equal 3 here. So it doesn't work there either. That's a sad face. It really is a sad face. Let's try that again. So we can't plug it in that second row even though we see that 3. And 3 obviously isn't greater than 4. That's why that one's not possible. All right, keeping all these in mind, making sure you have work shown to support your answers, the better you feel about this review worksheet, the more confidence you should probably have going into the test tomorrow. I'm available during the school day for Google Meet help, or you can email me with questions. Otherwise, be ready to go right when the bell rings for our test tomorrow.